Welcome to this explainer, everyone. Today, we're attempting something completely different. We aren't just going to sit here and grind through basic math. No, we are going to learn how to actively hack the Cambridge Mathematics exam strategy. And look, I don't mean hack in the literal break into a mainframe sense, but rather, we are going to systematically reverse engineer the examiner's grading rubric. We're looking for that hidden backdoor into every single question. Our specific target today, mastering the equation of a straight line. Now, whether you are tackling the 0580 syllabus, jumping into the deep end with 0606 additional mathematics, or navigating through 4024, 4037, or 4040, the equation of a straight line is an absolute fundamental battleground. It sounds incredibly simple, right? Just finding your gradient and y-intercept. But let me tell you, the way Cambridge tests this exact concept is specifically designed to trip you up. By the end of this session, you are going to have the ultimate backdoor strategy to bypass all of those traps, work way smarter instead of harder, and secure those easy marks that other students just leave sitting on the table. So grab your notebooks, get comfortable, because we are going straight to the source of what makes a top-tier candidate. So let's start with the big question. What truly separates a B grade from an A star in additional mathematics? Is it natural genius? Is it sitting in your room memorizing 1,000 different textbook formulas until your eyes blur? Think about it. When you are sitting in that utterly silent exam hall, staring down a complex past paper question, maybe one of those nasty ones that seamlessly blends coordinate geometry with calculus, what is the invisible barrier keeping good students from becoming truly great students? Well, we've analyzed the principal examiner reports. We've gone incredibly deep into the data of where thousands of candidates literally bleed marks every single year, and the answer might genuinely shock you. It's not about your raw computational speed. It's not about having a human calculator for a brain. The real difference between an average grade and a top-tier grade comes down to something so much more fundamental to how you approach the paper itself. Okay, let's dive into this. The real answer? It's systematic analysis and evidence-based reasoning. You see, the conceptual framework for the equation of a straight line draws incredibly heavily on these exact principles. The examiner isn't just looking at the bottom of the page to see if you magically arrived at the final number. They couldn't care less about just the final answer. They want to see the entire architecture of your thought process. They prioritize structured analytical depth over superficial breadth. An A-star candidate doesn't just calculate, they logically justify every single step. They provide undeniable evidence for their reasoning. They use precise mathematical definitions, they establish causal relationships, and most importantly, they show exactly how they moved from point A to point B without any gaps in logic. This is exactly what we mean when we say working smarter. We literally need to stop thinking about math as just finding X and start treating it as presenting an airtight, evidence-based legal argument directly to the examiner. To get us there, here is our roadmap for today's explainer. First, we'll outline the challenge. Second, the strategy reveal. Third, the transformation. Fourth, we'll dive into an interactive workshop. And finally, we'll lock down the final system. Act 1, the challenge, decoding the 0606 exam pitfalls. Let's look at exactly where things go wrong. Let's explore two incredibly common student archetypes to really illustrate the biggest pitfalls we see time and time again. First up, we have Alex. Now, Alex is the student who stays up until 2 a.m. memorizing absolutely every formula in the textbook. When faced with a straight-line data chart, Alex panics and just dumps all those raw math facts onto the page. Y equals mx plus c, the gradient formula, the perpendicular bisector rule, the midpoint formula, it all just gets vomited onto the paper. But there is absolutely zero analysis. Alex is providing superficial breadth, but totally lacks analytical depth. The examiner sees this page and thinks, okay, cool, you know formulas, but can you actually apply them to this specific unique context? And boom, marks are lost. Then, on the flip side, we have Sam. Sam is incredibly fast. Sam's main goal is to finish the entire paper 30 minutes early. But in that absolute rush, Sam completely misses the specific command word requirements. If the question explicitly says, show that the equation of the line is a certain value, Sam just writes out a basic calculate step and skips the evaluative proof entirely. If the question says evaluate the performance, Sam just gives a numerical fraction without any written context whatsoever. Sam drops easy marks constantly because Sam is answering the question they wished was on the paper, not the specific question the Cambridge examiner actually asked. You absolutely cannot afford to be an Alex or a Sam. Now, what is really fascinating is how this matrix actually reveals the hidden architecture behind the exam itself. The assessment objectives for something like the equation of a straight line target 3 distinct cognitive domains. The first is knowledge and understanding. This is your absolute baseline, recalling formulas. It's necessary, sure, but it only offers superficial breadth. You are not getting an A-star just for knowing the gradient formula. The second level is application. This is where you start demonstrating cross-topic connections. The principal examiner reports explicitly highlight that candidates who reference cross-topic connections, like, say, linking a straight-line tangent directly to a calculus derivative, achieve significantly higher marks. This shows real analytical depth. But the absolute highest tier? That's analysis. This is where the assessment goal is purely evaluative thinking. The focus is on providing systematic evidence. Top-scoring candidates demonstrate this evaluative thinking by questioning their own assumptions, considering different mathematical perspectives, and justifying their decisions with solid, unshakable evidence right there on the page. Act 2, the strategy reveal. It is time to start working smarter, not harder. So, the absolutely crucial point here is applying a framework you might actually recognize from your English or history classes and bringing it directly into your mathematics exam. Yes, you heard me correctly. We are using the PEEL framework: point, evidence, explanation, link. I know it sounds crazy for a math paper, but stay with me. In a complex straight-line problem, your point is identifying the key mathematical element. For instance, clearly stating that the gradient of a perpendicular line must be the negative reciprocal of the tangent. Your evidence is the raw data you extract from the question, the specific coordinates you are substituting. Your explanation is the actual execution of the analysis, your clear step-by-step working. And finally, the link. This is where 80% of students fail. You must link your final equation back to the original context of the question, presenting it in the exact format they requested. Let's see how this actually translates into a strict, repeatable mathematical procedure. When we translate the PEEL method into a specific, actionable procedure for the exam, it becomes your ultimate hacker sequence. Step 1, deconstruct the question. Literally highlight or underline the command words. Are they asking you to find, show that, or hence evaluate? These words dictate your entire strategy. Step 2, extract relevant data. Pull those specific coordinates and gradients out of the confusing word problem noise. Step 3, execute with clear notation. This is your systematic analysis in action. Lay out your working cleanly. Step 4, verify results. Take a deep breath, plug your final calculated coordinate back into your straight line equation, and see if the left side actually equals the right side. It literally takes 10 seconds, and it saves entire grade boundaries. And step 5, present with correct terminology. Strict conventions apply here. Proper headings, correct variable names, appropriate algebraic formats, and extremely clear annotation. Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's talk about your ultimate safety net in these exams: the method mark strategy. This is arguably the single most important concept you will learn from this explainer today. The examiner alert from the annual reports is crystal clear. Students lose a tragic amount of marks simply by not showing their working. Listen, even if your final answer is completely, totally wrong because you accidentally dropped a negative sign in step 2, method marks can absolutely save you. If you lay out your procedural framework with incredibly clear notation, the examiner can and will award you marks for demonstrating the correct procedural steps. You are quite literally getting points for your systematic analysis, regardless of a silly arithmetic error. This is exactly why the execution with clear notation step we just talked about is non-negotiable. Do not hide your brilliant thought process inside your calculator. Put it out there on the page. Act 3, the transformation. Let's talk about securing the easy marks. Straight from the Cambridge Principal Examiner reports, here are the top 3 warnings. These are the specific, agonizing traps where candidates hemorrhage easy marks every year. First, students completely forget to include the proper format in their equations. If the question explicitly asks for the equation of a straight line in the form ax plus by plus c equals 0, and you just casually leave it as y equals mx plus c, you automatically lose that final mark. It is an absolute tragedy of simply not reading the command word. Second, students forget to check their format and presentation. I'm talking about missing coordinate brackets, incredibly sloppy handwriting where a 5 looks exactly like an S, or failing to provide clear annotation. The examiner cannot mark what they literally cannot decipher. Third, answers are not specific to the context given. If the straight line represents a cost function over time and the question asks for an evaluation of the gradient, just writing m equals 2 is not going to cut it. You need to explain in plain English that the cost increases by $2 every single minute. Context is always king. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now, let's talk about a real game changer. Cross-topic connections equals significantly higher marks. The 0606 syllabus absolutely loves to combine topics to test your analytical depth. You will rarely just get a basic, standalone, straight-line question. Instead, you'll be asked to find the equation of the normal to a curve. This means you have to differentiate first to find the gradient of the tangent, flip it using the negative reciprocal rule for the normal, and only then formulate the straight-line equation. Recognizing that theoretical architecture, how straight lines seamlessly integrate with calculus, trigonometry, or advanced coordinate geometry, is exactly what pushes you out of the B-grade plateau and into the A-star bracket.
Act 4, Interactive Workshop. Let's put this into practice and test your hacker skills.
All right, challenge number 1. I want you to imagine a massively complex data table sitting right there on your exam paper. It's got scattered data points, a tricky line of best fit, and maybe some really strange variables on the axes, like log y plotted against x. The clock is ticking down. You have 60 seconds. Can you extract the chord trend without panicking? Remember our exact framework. Step 1, deconstruct. What is the actual question asking? Step 2, extract relevant data. Do not stare at all the noisy data points. Look precisely at the y-intercept. Look at the gradient. What does the steepness of that straight line actually tell you about the causal relationship between those two variables? If you try to calculate everything all at once, you're going to freeze up. But if you systematically extract just the gradient and the intercept, you can decode the entire underlying chart in under a minute. It's all about focus. Let's step it up to challenge 2. Find the flaw. Imagine you've written out an entire page of working. You found your gradient perfectly. You plugged it into the standard y minus y1 equals m times x minus x1 formula. You beautifully expanded the brackets. You proudly wrote down your final answer. But the examiner's red pen strikes, and you are losing marks. Why? More often than not, the flaw isn't a mathematical arithmetic error. It's actually a structural one. Did you skip the line of working that explicitly shows the substitution of the coordinates? Did you just write the final rearranged equation without showing that intermediate algebraic expansion? That missing sentence, that crucial missing visual evidence of your systematic analysis, is exactly where you bleed marks. You absolutely must support every single leap in mathematical logic with written evidence on the page. Challenge 3 is the ultimate test of an A-star candidate: comparative analysis. Sometimes higher-order exam questions demand you compare two completely different straight-line models. To secure top marks here, you must follow these extremely strict critical analysis rules. First, you need to identify both similarities and differences between the lines. Maybe they share the exact same gradient, making them parallel, but they have completely different intercepts. Second, you must use comparative connectives to structure your reasoning logically on the page. Third, you absolutely have to support each comparison with numerical evidence drawn directly from your calculations. And finally, you must draw a definitive conclusion about their relative importance in the context of the word problem. I challenge you right now. Mentally, write a perfect Peel paragraph comparing two parallel lines using these exact rules. It's this high level of evaluative thinking that guarantees exam success. Act 5, the final system. Your Cambridge success starts here. Bringing it all together, these are the 3 absolute unbreakable rules of our answering system. This is your hacker's toolkit to take into the exam hall. First rule, command word decoding. You should never, ever start a calculation without physically circling the command word on the paper. You need to know exactly what show that, find, or evaluate requires of you structurally before you pick up your calculator. Second rule, Peel framework application. Make your mathematical point clearly. Show your raw numerical evidence. Logically explain your working for those all-important method marks, and finally link it right back to the question's specific format and real-world context. Third rule, the time management matrix. Please, do not spend 10 minutes sweating over a 2-mark question. Allocate your precious exam time based entirely on the analytical depth required. Superficial breadth questions get less time. Deep, evaluative thinking questions get more. I want you to listen to this direct quote pulled straight from the examiner reports. Let this really sink in. Top-scoring candidates demonstrate evaluative thinking by questioning assumptions, considering different perspectives, and justifying decisions with evidence. This right here is the exact mindset you need to adopt today. When you look at an equation of a straight line, I don't want you to just see floating numbers anymore. I want you to see a mathematical model that requires your justification, see it as a piece of evidence that actively supports a broader mathematical conclusion. When you shift your perspective from just passively doing math to actively presenting an evidence-based argument, you elevate the quality of your entire paper. And because I want you walking into that exam hall feeling unstoppable, here is a quick, highly actionable memory hack to lock this standardized sequence into your brain. Create a mnemonic using the first letters of our procedural framework. Deconstruct, extract, execute, verify, present. DEEVP. Maybe think of it as does every examiner value presentation. Honestly, whatever works for you. The whole goal here is to have a deeply ingrained mental trigger so that the very moment you see a terrifying complex straight line question, you don't panic, you just take a breath, run the sequence, apply the system, and hack the question.
And this brings us to our absolute final, most critical reminder. Even if your final answer is totally wrong, method marks can save you. Show you're working. Be systematic. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
We've covered a truly massive amount of ground today, from avoiding common traps to mastering the Peel framework and securing those vital method marks. The back door to this exam is wide open for you now. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep analyzing, keep verifying, and I'll see you in the next explainer.